Once again, welcome to e-learning program. In our previous video, we have learnt about line symmetry, also known as reflection symmetry or mirror symmetry. But why reflection symmetry? Because in each figure, one half of the figure is the reflection or mirror image of the other, and the line of symmetry work as a mirror, which creates reflection of objects. As we have example of spectacles here, in which left part of the dotted line act as an object while the right part act as the reflection, or we can say that the right part act as an object while the left part becomes the reflection of that. Similar thing happens with butterfly also. Now the question arises, is there any other way to get symmetry? Take one example here. Does this figure has line of symmetry? No. Do we get reflection of one part of the figure to the other side? No, isn't it? Now rotate this figure around a fixed point and check how many times do you get the original figure in one complete rotation? You will say 4 times. It means we get 4 times a situation in one complete round when it becomes difficult for us to find out from which point we started our work. All the 4 situations become identical to the previous one, and such type of symmetry is known as rotational symmetry. So we can say that a figure is said to have rotational symmetry if it fits onto itself more than once during a complete rotation. Look at this flower and check. If we rotate this flower around the center point, we get 4 situations. It means we get 4 identical figures to the previous one. That is, 4 times we get the original shape in one complete rotation. Let's understand with one more example. Now this time you have a smiley face. Rotate this now at different angles and tell me how many times do you get the original shape? Means the face in which eyes, mouth and other parts remain at the original place. You will answer we get the original shape after completing one round only, that is after covering an angle of 360 degree. Before 360 degree, there is no place when we get the shape identical to the original shape. So we can say that this face doesn't get original face before 360. Therefore, this figure has no rotational symmetry. So what is the conclusion now? A shape has rotational symmetry when it still looks the same after a rotation of less than one full round. Let's talk about figures or shape in our surrounding which shows rotational symmetry. Flowers, football, mobile, geometrical shapes like equilateral triangle, rectangle, square, circles and many more shapes are there which show such type of symmetry. Now I ask you a question. Identify which of the following has rotational symmetry. Take your time and answer. Your answer would be starfish. But why? Why have you chosen a starfish here? You will say, because when we rotate this figure, it gets original shape 5 times in one complete rotation. But if we rotate jellyfish, we do not get any angle when we get the original shape. Hence, this star shape has rotational symmetry. Now let's understand another term associated with such type of symmetry, and that term is order of rotational symmetry. We have Mercedes logo here. Rotate this figure now. How many times this figure gets the original shape in one complete round? 3 times, isn't it? This number 3 here is known as order of rotational symmetry of this logo. So we can say that the number of times a figure fits onto itself in one complete rotation is called the order of rotational symmetry of that figure. We have equilateral triangle here. 3 times we get the original shape in one complete rotation, isn't it? This we all know. Hence, the order of rotational symmetry is 3. Similarly, we have square in which we get original shape 4 times in one complete rotation. Hence, the order of rotational symmetry of a square is 4. Take the example of alphabet S. S repeats itself only twice, that is at an angle of 180 degree and 360 degree. Hence, its order of rotational symmetry is 2. Now, if you want to find out at what angle do we rotate to get the original figure, then what should we do? You have a figure here, and this figure has order of rotational symmetry 3. Divide 360 by 3. Why 360? Because at one point the complete angle is 360. When we rotate any figure, the angle which is formed is 360. So when 360 is divided by 3, we get 120. So if we rotate figure, we get first time original shape after covering 120 degree. If we continue this process, then second time we get original shape after covering 120 plus 120, that is 240 degree. And third time we get after covering 120 plus 120 plus 120, which is equal to 360 degree. So we can say that angle of rotation is equal to 360 degree divided by order of rotational symmetry. We have example of 8. This number 8 has rotational symmetry of order 2. We all know this. When we rotate this 8, 2 times we get the original shape in one complete rotation. Hence, if we want to find out angle of rotation here, we can say that angle of rotation is equal to 360 divided by 2 is equal to 180 degree. It means that first original shape we get after 180 degree and the second original shape we get after covering 180 plus 180, that is 360 degree. And we have a very special shape with us. See this wheel which is circular in shape. This figure gets identical shape after covering every angle, isn't it? Because we know that in the case of circle, if we rotate little bit our circle, we get the original shape and it becomes very difficult for us to identify which one is the previous one. Hence, its order of rotational symmetry is infinite. So, what about its angle of rotation? Angle of rotation becomes here 360 divided by infinite. We know that when we divide any value by infinite, we get a very small value. So, we can say that this value is very close to 0. I give you a question. Does these figures have rotational symmetry? If your answer is yes, then what is the order of symmetry and what is the angle of rotation in these cases? You check your question and answer me. Take your time for this. In first case, your figure is alphabet X. So we know that if we rotate this X figure and complete one complete round, we find 2 places when we get the original shape. Hence, the order of symmetry here is 2. And if we want to find out angle of rotation here, we can say that 360 divided by order of symmetry, which is 2, equal to 180 degree. So, first time we get original shape after 180 and second time we get after covering 360 degree. Take another example of semicircle. Do we find any rotational symmetry here in one complete round. Rotate this figure. We find that there is no place when we get original shape. Even if you rotate this and check all angles present here, at every angle we find different figures which does not match with the original one. Hence we can say that this figure has no order of symmetry. Let's revise what we have learnt in this video. A figure is said to have rotational symmetry if it fits onto itself more than once during a complete rotation. A shape has rotational symmetry when it still looks like the same after a rotation of less than one full round. And the number of times a figure fits onto itself in one complete rotation is called the order of rotational symmetry of that figure. Now I give you an assignment which will check your knowledge whether you have understood this concept clearly or not. So check your knowledge and answer these questions. Your first question is, draw an isosceles triangle and show its rotational symmetry. And your second question is, find the order of rotational symmetry of the following figures. Your first one is parallelogram, second isosceles trapezium, third letter V, and the fourth one is a circle with radius 4 centimeter. After solving your question, you will be able to check whether you have cleared your concept or not. So, thank you and bye-bye.